Hi, my name's Kihao. Today we're going to go over Chapter 2 data. So last week we went over Chapter 1 Intro to Python. Today we're going to briefly go over what we learned last week, and then we're going to jump right into Chapter 2 data. Before we do that, go to CodeSkulptor Thinkific page and click Python. And also open up CodeSkulptor. CodeSkulptor is the in-web IDE that I'll be using to code. So these links will be in the description below. Also, a link to a slideshow, a Google slideshow, will be in the description below. This will help you keep track of what I'm saying throughout the lecture. Also, there will be another CodeSkulptor link that will be in the description below. This will contain all the practice problems we will be doing in this chapter 2. So, let's review what we learned last week. What is Python, and why are we learning it over other languages? Python is everywhere, whether it be in data science fields like machine learning, web development, or game development. Python has a lot of advantages. Python is beginner-friendly and has robust libraries. What I mean by beginner-friendly is that it has very intuitive syntax. Okay, let's review comments. Comments are part of your code that are ignored by your computer. These code are only used to clarify your code and make them more readable. A single line comment looks like this, while a multi-line comment looks like this. Input, output. So to accept an input, all we have to do is input. And then to output something, all we have to do is print. There are multiple ways to print. If you just print normally, it'll just print. So if I go here and I print 1, 2, 3, it'll print 1, 2, 3. If I put comma in between, it'll put a space when we print. If I put a plus sign, well, this plus sign only works for strings. So I do I, and then I do plus. It'll add them together and print it. So those are the ways to print. And also, we're going to talk about compile time and runtime. Compile time is when the compiler is checking for errors. This occurs when the code is compiling. So this occurs before the code is run. Here, we're checking for syntax errors. So for example, if I spell print run, I do like print 1, it's going to do name error, right? So name error is a syntax error. And this happens before the code is run. And runtime error occurs when we're running the code. So for example, if I do print 1, and then I do print 1 divided by 0. Since 1 divided by 0 can't work, it's going to error at this point. But this error happens after we run the code. So when we do this, we run this code, and then we get to this code, and then it says 0 division error. So that is compile time versus runtime. So if you aren't understanding any of these, please go back to the last video. Now we're going to go over Chapter 2 data. So data is information stored inside the computer. And data types is how the computer recognizes the data. In Python, we have many different data types. The first 4 that we'll be learning are strings, integers, floating numbers, and booleans. So strings are just a series of characters, includes inside quotation mark, and integers are just normal numbers like 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And floating numbers are basically integers with decimal. So it can be 1.2, 5.4, 2.6, and 1.8. And booleans are just true or false. So let's go to CodeSkulptor. So let's just do string 1 equals I am 17 years old. Right, so inside the string, you can put any single character. Right, so you can put numbers, you can put letters, you can even put symbols. And also, you can put stuff inside one quotation mark. And that also counts as a string. So if I do 17 years old, and then all these symbols, and I print both of them, they're going to be hold on. They're going to be exactly the same. And now if I do print type string 1 and I print type string 2, it's going to give me the type of these variables. So variables are things you can store data in. We're going to go in depth into variables after we finish data types. So those are strings. Integers are just normal numbers, right? So if I just do, hold on, integer 1 equals 12, integer 2 equals 0, integer, no, let's just do negative 12. As negative still is an integer. So if I do print integer 1, and then I print integer 2, and then I print integer type integer 1, which will give me the type of this variable. And I do type integer 2, it's going to give me the type of integer 2. When I do it, I'm going to get negative 12 from this. I'm going to get 0 from this. I'm going to get integer int, class int from this, and get class int from this. So let's look at floating numbers. So floating numbers are just integers with decimals. So let's just do float 1 equals negative 12.5, negative 12.4, I mean, float 2 equals 0.0. So after I put point, it's going to become a float. Even though it's a 0 after the point, it's still considered a floating point number in terms of type. So now if I do print float 1, you print float 2, if I do print type float 1, if I do print type float 2, I'm going to get negative 12.4 from this, 0.0 from this, float, class float from this, and class float from this. So as you can see, these are float, these are integers, these are strings. And let's look at booleans. So booleans, we're just going to talk about what booleans are. So we're going to be using booleans later on, such as in chapter 3. So booleans are just true or false. So if I do bool 1 equals true, and I do bool 2 equals false, when I do this, you can see that the true word and false word becomes purple. So in most IDEs, they'll tell you if a word is a keyword. By keyword, I mean a word that is reserved for Python and the user can't use it as a variable name. So if I do true equals 1, it won't work because you can't use the keywords as a variable. So if I do print bool 1 and I print bool 2, it's going to be true and false. Now if I do print type bool 1 and I do type bool 2, and also don't forget that the parentheses have to be somewhat symmetrical. So like if you have one parenthesis here, you must have another parenthesis here. If you have one here, you must have another one here. So now if I do that, it's going to be true for this, false for this, class bool, class bool. So now let's move on to variables. So variables, as I said before, are things you can store data in. So if I want to remember string 1 as this, and when I reference it later, so I just put print string 1, later on, the computer still memorized it from a long time ago. Right? So let's see what's actually happening when we declare a variable, or that is when we do something equals something. When we write the code, variable 1 equals 5, we're assigning a label called variable 1 equal to 5. So we have a label Wait, hold on. We have a label called variable1, and we assign it to 5. Now, when we reference variable1 later, such as when we print it, it's going to look at what value the label is pointing at. And the value of variable1, the label variable1 is pointing at is 5. So when we print variable1, it's going to print 5. But what happens when we have the same variable name, but we assign it to a different thing? So I just do the code variable1 equals 6. What happens? Well, the variable label gets assigned or is pointing at a different value now. Now it's no longer pointing at 5. When we write the code, print variable1, now it's going to print 6. Why? Because now the label's referencing to 6. So when we reference variable1, it's going to be 6. So let's do some practice. The practice problem that we'll be doing is called stored data. The problem says, set a variable name message to hi, it's a good day, and a variable name x to 24. So now, if I go to stored data, and I take this, and I put it in CodeSkulptor, we can do the problem. So now, I'll give you guys a few minutes. Please pause the video, and after you unpause, I'll be doing the problem. Hopefully now, you have finished the problem. So now, we just do message equals hi, it's a good day, and a variable name x to 24. That's all you have to do for this problem. Okay, let's move on to the next section. String or numbers. Strings are surrounded by quotation marks, and numbers are just 1, 2, 3, 4, 5. Right? So what happens when we add strings versus what happens when we add numbers? So when we add strings, we're going to place them side by side. So if I do string 3 equals I am, and I do string 4 equals he how. Right, so if I print string 3, wait, hold on. If I print string 3 plus string 4, it's going to add them side by side. So now it's going to be I am key how. But when we add numbers, string integer 3, let's call it, or let's assign it to 9, and integer 4, let's assign it to 11. So when we add integer 3 plus integer 4, it's going to be equal to 20. Right? So this is just normal arithmetic. While this places the second string right next to the first string. Right? So this is called string concatenation. Before we move on to the next section, we're going to be doing a practice problem. The practice problem we're going to be doing is print data types. So the problem says, come up with 3 examples of each floating numbers, integers, and strings, and print them. So again, please pause the video. After you unpause the video, I'll be going over the problem. So now, hopefully, you have done the problem. So this problem says come up with 3 examples of each floating numbers, integers, and strings, and print them. So we just do float 1, or let's just do float 5 equals 1.1, float 6 equals negative 1.4, float 7 equals 0.0. Now we got to print each of them. And also, if you want to confirm that they are indeed float, you can do type, right? So you can do type float 5, and when we print it, it's float. So the problem just says you have to print the variable. And now we can just do print float 6, print float 7. Right, so that's coming up 3 examples of floating numbers and printing them. Now let's go to integers. integer 1, let's just do 1, integer 2, let's call it 19, integer 3, let's call it 27, and print integer 1, print integer 2, print integer 3. And now let's move on to string. So string 1, let's do my favorite is ice cream. And string 2, let's call it my favorite animal is cat. And no parentheses here. Okay, string 3 is, let's call it anything, right? So those are the 3 strings I chose. And now we're going to print the strings. So print string 1, print string 2, print string 3. And when you run all of these, you're going to get 1.1, negative 1.4, and so on, right? So we're printing 3 of each of these types. Okay, so that is print data types. Let's move on to the next section. Casting. When we cast a variable to another data type, we convert the variable's data type to another data type for whatever reason. We cast using casting functions such as int, float, string, and bool, right? So this is int, string, and many more. So let's move to CodeSkulptor to see this. So the 4 functions are int, string, bool, and float. So these functions are pretty intuitive. So when we have x as originally 5, if we want to change this to an integer, we just do print int x. So when we print it, it's 5, right? But because like when we print string 5 and int 5, it's the same thing. But we can check the typing using type. So we do print type int x. Don't forget the parentheses, right? So if we have one parentheses here, we must have another enclosing it. If we have another parentheses here, we must have another enclosing it, right? So when we run this, it will say int. If we just do type x, it will say string, right? So you can also change this to float, right? So if we do float x, it will be, wait, hold on. I forgot a parentheses. So it will be float, right? What about Boolean? Does Boolean work? It does work, right? But then when we do Boolean, anything that's greater than 0 is going to be true, right? So when we do bool x, it will be true. So these, you don't have to worry about these, but just know that you can convert to Boolean, from integer to Boolean. That is possible. So what about if we have a string? So let's just do string 1 as the actual value, and let's convert this. Let's convert this into integer. I forgot parentheses again. Hold on. Here it says value error. Invalid literal for int with base 10 string 1. So as you can see here, Python is smart. It is able to tell that this cannot be integer, right? So the limitation to casting is that the original value of the thing that we're going to cast has to be convertible to the new data type, right? Because string 1, it cannot be converted into an integer, no matter how you look at it. But here, 5, it can be an integer. We just do int x, and int x will give you 5. But int string 1 will not work. So when we run this, hold on, I forgot parentheses again. This will error, right? So I'm going to comment this out and say this will error. Similarly, you can convert from string here to float, right? Because originally x, the value 5 inside x, can be converted into a float. So when we do this, hold on, got parentheses again. When we do that, it'll give us float, right? But then if we do y equals string 1 again, let's do string 1 again. If we do print type float y, it still won't work. The reason it won't work is, again, the original value cannot be converted to a float. So no matter how Python looks at it, it cannot be a float. And since Python is smart, it will just error. So this will error because the original value here cannot be converted to float. This will error. So now you have a good intuition about when you can convert, right? Like anything that has the original value that can be converted into the new data type can be converted. Okay, let's move on to some practice. Let's do float. The problem says, write a program that takes a number from the user and stores it in a variable. Cast number to an integer and store another variable. Then print the floating point number, parentheses equals integer, parentheses. Also print the type of the floating point variable. Remember, type of the variable name will return the data type of a variable. So I think this is a little bit unclear. So I'm going to modify it a little. So it says float. Write a program that takes a number from the user. Hold on. It should be takes a float from the user and stores in a variable, cast number to an integer and store another variable. So what you're doing is you're taking a float from the user. So you're doing whatever variable, and then you're taking a float from the user. So you have to do input and then make it a float. And then you store in a variable and then cast the number to another variable and make it integer. And then after you finish with those casting, you have to print this equals this. So for example, if the user put 5 as an input, if the input is 5, then the printed answer is 5.0 equals 5. So pause the video. When you unpause, I'll go over the problem. Okay, so now hopefully you have finished the problem. So now we'll be going over it. So the first thing we're going to do is make a float variable. So float 1 or whatever you want to call it. Float 1 equals float input. And then input of float. Right, so remember when you put something inside the input, it's going to be here in the header. And also remember, the input is by default a string. So we're making a float, we're going to make it a float first. And then we're going to make it an integer. Integer equals int float. And then it says print floating point number, parentheses, parentheses, equals integer. So now we just have to print that in that format, right? So if the input is 5, then it will be parentheses 5.0 equals 5 parentheses, right? So what you have to do here is parentheses, comma or plus, either one, and float 1 plus comma, not comma, quotation marks. So like if you remember, plus is string concatenation. When we add strings, it's called string concatenation, and string concatenation is when we put two strings right next to each other. And now we just do plus space equal space plus, wait, hold on. You can include this in this part of string, and then plus, hold on, plus the integer one. And then we add the closing parenthesis. Okay, so now, after you print this, hopefully it should be working. wait, hold on. I forgot a plus sign here. And this, wait, hold on. There shouldn't be a plus sign here. Yes, so it should be parentheses plus float plus parentheses plus the equal sign spaces plus parentheses plus the integer 1 and then plus the parentheses and then closing parentheses for print. And when you run this, if we run 5, it should be, hold on. Oh, okay. Yes, so I accidentally put float instead of float1. So float1 is not a variable and it's also a keyword. So it should be float1. Now it should be working. So if I put 5, hold on. Oh, yikes. I forgot to put string. I forgot to convert float to string. So if you want to add string with string, both of them have to be string. So the mistake I did here was that I added a string with a float and then a string of an integer. So I have to convert these into string in order to add them, right? So I got to make them string so that when I add them, it becomes a string. And now it should be working. If I put in 5, yes. As you can see here, it's 5.0, parentheses, parentheses equals 5. And that is your answer for problem float. And now we'll be going into variable naming. So we talked about how variables are things that you can store data in. We can pretty much have a lot of different names, string 1, integer 1. So as you can see here, the variable, we can put any letters we want, right? So we can put float1, float2, or integer 1, integer 2. But we cannot put the integer in the front. If we put the integer in the front, it's going to error. So there are some limitations to naming, right? So one rule is that for the naming, the integer cannot be in the front. The integer has to be at least the second letter or after. And also, some symbols don't work for the naming, right? So if I put money sign float1, that will not work. Right, so those are limitations. Some symbols don't work, and you can't put integer as the first letter. Also, you can also put capital case letters, right? So a style in Python is that capital case means a constant. So a constant is something that won't be changed throughout the program, right? So this is a style. That means this is not strictly enforced inside Python, but programmers like to follow this rule. The rule is that capital case is constant. For example, if I have 7 as my birthday number, and this constant won't be changed throughout, I'm going to make it a capital case. So if I run this, I put, or this is a previous code, right? So if I run this, the Python doesn't seem to care that it's capital case, but it's a programming style. So there you have it. That is chapter 2. And before we end, let's do another practice problem, which is favorites. The problem says, write a program that asks the user for their favorite food, favorite drink, and the name of their favorite person. Output a statement that uses all this information. Be creative. Okay, so let's do this problem inside CodeSkulptor again. Okay. I'm going to comment this out so that it doesn't affect my code later on. Because if I don't comment this out, when I run it, it's going to ask for the input here, which is not what I want. So now we're just going to do the next problem, which is this. So please pause the video. When you unpause, I'll be going over the problem. So now, hopefully, you finished the problem. So let's start the problem. It says, ask the user for their favorite food. So food equals input. What is your favorite food? As I said before, input is by default a string, right? So since letters can only be represented in strings, we don't have to change this to integer or anything. We can just keep it as a string. And next, it says ask for the favorite drink, right? So drink equals input. What is your favorite drink? And it also asks, and the name of their favorite person. So favorite person equals input. What is the name of your favorite person? So that's all the input. Now we have to output a statement that uses all this information. So for me, I would just do food, no, not food. I like plus food plus and plus drink while fave person doesn't. Right, so here we're not converting these to strings because they're already strings. Right, so since they're already strings, we don't need to do any conversion. So now, after we do this, hold on, after I put a period, and then when we run this, and then just do some random inputs, let's say Juice and Sam. When we run this, it's going to be I like hamburger and juice while Sam doesn't. So that is my answer to favorites. Hold on, I'm going to make these more readable. Hold on, it should be, the first problem was store data. It should be practice assignment 1, print data type. Let's call it practice assignment 2. And let's call the float practice assignment 3. This should be a practice assignment 4. So there you go. Those are the content. These are the class notes that we did today. Now I'm going to briefly talk about what we learned today. So today we learned that data is information stored in the computer. Data types are how the computer recognizes that information. We learn data types because when we encounter data types when coding, we want to know what we can do for each data types. So the first 4 data types that we learned in this class and are covered today are string, float, int, and boolean. Variables store data for later use, and that's why we learn them. There are limits and style to naming. So like limits as in the first character cannot be a number, and also some symbols don't work. And style as in all capital case means a constant. And there are also differences between adding strings and numbers. So like if you remember, strings, adding them is called concatenation. When we add strings, we put the second string right next to the first. And when we add numbers, it's just simple arithmetic. And then we learned about casting variables. So we converted a variable's data type to another using casting functions, such as int, float, string, and bool. So we want to cast for whatever reasons, such as when we want to add strings. So if we want to add a string to an integer, we have to make an integer string first. When you cast, the original value has to be convertible. So like if the original value was 5 and we cast into integer, it would be working. But for example, let's see here. If we had string 1 and we try to cast it to integer, that will error because Python is smart enough to know that string 1 cannot be integer. Feel free to do the quiz over here, chapter 2 quiz. This will help you.